In this video, we are going to talk about transformations of quadratic equations. Uh, I'll do this as best as I think you'll need that will help you in your schooling, but if there are any particular types of questions around this that you are interested in knowing how to do, send me a comment and I can be more explicit. But generally, you can do these transformations on any type of curve. And today we're going to focus specifically on the quadratic curve, but some of what I talk about works in anything. All right, so I'm using this software called GeoGebra. It's quite nice for doing quick plots. If you want to plot something and play around with how the plot works, you can see the name in the top left corner, and it is a free open source app. So, uh, if you think it'll help you learn, you can use this too. So what I've got plotted right now is like a really simple quadratic equation. It's just entirely f of x equals x squared. So if you're not into the f of x notation yet, don't worry about that. It just means it's some combination of x's on the right side. So x squared, of course, that means when x is 1, you square 1, and this is f of x on the y-axis. So 1 squared is 1, 2 squared is 4, minus 2 squared is also 4. So that's why the shape looks like this. Every time you take the x value, square it, and then you, right here, this is a point x squared in terms of xy coordinates, and it's like that everywhere in this curve, though. That y value, which is what f of x is equal to, is always equal to x squared. Okay, so well, we can't see 9, so 3 squared is 9, and that's way up here somewhere off the screen. So now transformations of a quadratic equation. What can we do? Well, we can move it up and down. We can move the curve left and right, and we can even stretch the curve. We could stretch it vertically. We could stretch it horizontally. But it's somehow equivalent to, a horizontal stretch can be written in terms of the other transformations. I'm getting into the weeds too much here. Let's just get right into it. Okay. So I want to do a vertical shift. I want to move the whole function up, say. Let's say I want to move it up 2 so that it starts here and goes like that. Well, I can just take this function and, maybe this one's obvious to you. You add 2. That'll shift the whole function up. I could also subtract 2, and that'll shift the whole function down. So we could put something like just add a constant to that function and it will shift the entire thing up or down. Okay, so that's vertical shifts. Let's talk about them each separately, and then I'll add some more constants to this first equation, and we'll see how we can move it around with the neat sliders that you can put into GeoGebra. Okay. So we shift it up and down. What if I want to move it left and right? Okay, so the trick I did to shift up, by the way, it works for any function. You take a function and then you add something to it, you're going to shift the whole thing up, no matter what the function looks like. Now to shift something to the right, you actually have to subtract it from x. So you'll see if I take x minus 2, and replace the x's with this x minus 2, the whole thing will move 2 to the right. Okay, right now, this is equal to 0 when x is 0. And once I do the substitution, that same spot where y is 0, it's going to happen where x is 2. Because now x has to be 2 to make that 0. Okay, let me show you more what I mean. Instead of x squared, we're going to write x minus 2 squared. So where there used to be an x, now there's an x minus 2, and you can see the graph moved 2 to the right. It works like that in any function. Doesn't matter what the function is. And of course, if I add 2, it's going to move to the left. Now, that's kind of opposite from those vertical transformations, right? Here, if I add 3, it goes up. Uh, Whereas if I add to the x, it moves left. Maybe you might expect it to go right, but adding something here makes it go left, right? X plus 2, it's now centered at minus 2 here. Okay, so yeah, the vertical transformations and the vertical shift, horizontal shift, they're similar. The horizontal shift, maybe the sign is different than you expect. Okay, let's go back to our original x squared function. And we can also stretch the function. So we could say multiply this by, let's multiply it by 5 just to make it obvious. So 5 times x squared. And see it all kind of got stretched. Like, you grab the thing and you pulled it up, and I'm stretching out the function. They call that a vertical stretch, what I just did there. And now it's 5x squared, and that 5 is doing the stretching. And what that means is now when x is 1, I square it and multiply by 5 to get the y coordinate. So you can see how that ends up shifting everything further up. And now for x equals 2, I got to square it, which is 4 multiplied by 5. That's all the way up to 20, which is up there somewhere. So multiplying by some number shifts it up, or does it a vertical shift, a vertical stretch. And if I want to kind of squish it vertically, I could multiply it by maybe 1/5. So a number less than 1 is going to shrink it down. It's like I'm pushing down on what the function was, and trying to squish it down a little bit. Okay, so those are the 3 types of transformations for a quadratic function. Let's type these in and play around with them a little bit. And if you get GeoGebra yourself, this is the kind of thing you can do. So I'm going to call my stretching number A. I'll just say A equals 1. I'll call my horizontal shift number H. I'll say H equals 0. And I will call my vertical shift number K, and we'll start with K equals 0. So with these values, it's just going to be the same as x squared. You'll see what I mean here. So now instead of x squared, let me plot, I'll put everything together, A times x minus h squared, and then plus k. So that's basically the 3 different things I did, but I put them all in there at once. Okay. But with the values of a, h, and k where there are, f of x still comes out to just be x squared, which is why it looks like this. Now, I'd like to make these sliders. I went and put this thing in the way there. I can make this a slider. Yeah. I can make this one a slider. I can't make that one a slider because, there we go. Create slider. So these sliders are neat because now I can just, like I can slide this vertical transformation. Right now it's 0, but I can pull it up to be, say, 3. And you can see while I do that, the function moves up. And while I do this, I'll move the function down, just changing k to a negative number. So if you have GeoGebra and you type in all this stuff, playing around with it helps to see what the transformations do. So that's what k does. Like I can shift it up 0. I'll shift it up 1. It doesn't have to be an integer. And you can change the slider so it goes in a different range, but right now all of these are between -5 and +5. That's fine. The horizontal shift. Oh, there, we can move it left and right. again, I've properly put in the minus sign here. So a positive value of h means it will go to the right. But I've got a minus here, whereas the vertical shift had a plus. So those come with opposite signs. So that h slides it left and right. Maybe I'll put it below the x-axis so we can see more of it. And then you can stretch it. So you can do all three of these things. Oh, and when a becomes negative, look at that. You get the mirror image, right? It turns it upside down. And right when a is 0, it's completely flat. You just see when a is 0, you multiply that by 0, it just kills this whole term off. 0 times that, gone. And it's just y equals minus 3.1 the whole way. So that's why when a equals 0, it does that. And when, a equals minus 1, obviously, it's just going to flip it all upside down on you. It takes all those positive numbers, turns them negative. So that's a mirror image, a flip. And you can also stretch it and flip it. So that's when you go a number different than minus 1. And between 0 and minus 1, it kind of flattens it out, right? And I can shift it up there. So those are transformations of a quadratic equation. I'm just playing around a little so you can see all the different forms that you get from changing the sliders. The important thing to remember is, so you just start with the equation f of x equals x squared. You might see this in your classes, y equals x squared. That means the same thing. And then adding the k shifts it up and down. Subtracting from x this value h. Notice it's important that we've got brackets around that whole thing before the square happens. That h will shift it left and right. And this a is the stretching parameter, so it stretches it or squishes it, and can also flip it upside down if a is negative. Okay, so that's transformations of quadratic equations. If there's some specific type of question you're getting in class that you want me to answer, let me know in the comments and I'll go through it. Bye for now.